everybody. Welcome back to In the Loop. We are a podcast by Texas Guadaloop. We are the University of Texas Hyperloop team. I am your co-host, Gavin Nader. I am the head of business, and I'm a senior studying economics here at UT.
I'm your other co-host, David Spiller. I'm head of engineering for Texas Guadaloop and currently pursuing my master's in mechanical engineering at UT. Today, we're joined with Ben James. Ben was one of our original team members for Texas Guadaloop, helping lead the team to 2 innovation awards. Outside of Hyperloop, he's worked at a plethora of technology companies and has a deep passion for innovation learning. Ben, it's great to have you on.
Awesome. Thank you. Slight correction. I wasn't part of the original 5 of Texas Guadaloop. I joined, I think, within 6 months of the starting date. And when I came in, I helped with their testing and electronics and helped get that up to speed. But as Vic laid out in his podcast on In the Loop, I wasn't there at the beginning.
Maybe you could help define for a little bit just like what your role with the team was and kind of like how that progressed over time.
Yeah. So at the time I was working at, I had just come from working from National Instruments, which is a big test and measurement company that makes some hardware and software. Phenomenal company, phenomenal products. I really enjoyed them working there. And when I heard about the Texas Guadaloop, I was at this startup, Longhorn startup thing. Bob Metcalf was there. So it's like all the people on this podcast are like part of my story too. And I met Vic and Deb and Pat and I think James was there too. And we started talking about Hyperloop, and I was like, it's really cool you guys are working on this. How are you going to levitate? And they started talking about air bearings. And I was like, air bearings? What about maglev? Because my senior design project at Georgia Tech, when I was an electrical and computer engineering undergrad, was a small scale maglev train. Loved that thing to death. There's many different forms of maglev of which I could go on forever. But anyway, I was really interested in maglev. They were really interested in air bearings, and we disagreed on things. We started talking about the pros and cons, and they were in one camp and I was in the other. And because we disagreed really well, it was enjoyable to learn from each other. And it wasn't like confrontational. It was more like, oh, that's really interesting. And they were very intelligent. I was like, I want to get involved. So I told them I was good at test and measurement, and I wanted to see what their testing strategy was for Texas Guadaloop. Vic looked at me and said, we don't have a testing strategy. And I go, great, let me come help you put one together. And I went in and their electronics was like a few Raspberry Pis and a few Arduinos and a mess of wires, and nothing worked. And it was quite fragile and terrible. And I said, okay, you guys work on this because I don't want to mess with what you're doing. I'm going to make a test platform based on the National Instruments MyRio. So in 2 weeks, I built up a test platform that had sensors that attached to all of theirs. And because I had to test it, I also had to create the functionality that they were aiming for. So in 2 weeks, I created the functionality that they had been struggling to do for 6 months, and the functionality on top of it to test it with a nice GUI. And when I showed them that, they were like, can we just use this? And I was like, yeah, that makes sense. And then I was in charge of coding and electronics in certain parts. Like there's a guy named Josh who's like a whiz kid at coding and electronics. So he did a lot of the printed circuit boards, and Vic was the team lead on electronics. But I came in and helped accelerate things quite a bit. And so the code architecture that was used in 2017, 2018, and 2019, even by MIT, was based off the architecture I came up with. And a lot of the way the sensors and like the safety protocols that were used were stuff that we thought of in 2017, because our design was very dangerous in the sense that you guys know what a RUD is, right?
Rapid unscheduled disassembly.
Yes. There were 3 distinct ways that our pod could undergo a RUD. One from pneumatics, one from the high voltage battery, and one from just going really fast and going off the rails. And so we had to have safety protocols in place for all 3 for it to autonomously shut itself down. And that's what I was in charge of. I was kind of a safety person, but more of an architect. And I was a bit of an instigator in terms of trying to get people to think outside the box and test things. One of my biggest ongoing messages to the team back in 2017, and especially in like 2018 and 2019, was, let's try stuff now. Let's not sit under a tree and design for months and then build it all 2 weeks before competition and then see if it works. Like, let's go build something next weekend.
So you're kind of a self-described mad scientist, and you kind of just spoke about it. Like, have you always been a tinkerer? Have you always been like building stuff? Did you do that as a child? And like, kind of why do you enjoy like the hands-on tinkering and building in the ruds?
Yeah, I have to partially blame that on my family. My dad was in construction. He owned a construction company out in Southern Oregon. And so I grew up on construction sites, seeing things get built. He had all kinds of cool tools. And I delusionally thought that I was also a builder like that. You're a little kid, you see your dad using a tool, you're like, I do that too. And my favorite delusional example of that is he had chainsaws to cut down trees. It's in Oregon. And he had a big chainsaw and he had a little chainsaw. And when I saw the little chainsaw, I said, that's my chainsaw because it's my size. And it wasn't until years later I found out they were both his chainsaws and I wasn't allowed to operate any of them. My mom is to blame for my infatuation with gadgets. They divorced and we lived with my mom. And we were two little boys, my brother and I. We were a lot to handle. And so she came up with this clever way of keeping us busy, where she went to Goodwill and went to the broken appliance section, bought appliances for like 25 cents a piece, cut the electricity cord so that we couldn't hurt ourselves. And then she took it out in the backyard and said, boys, I need your help. I need you to put all of the bolts in this bucket, all of the screws in this bucket, all the electronics in this bucket, and then motors in this bucket. And she used to just sit there for hours watching us take things apart. And that's how I got into understanding how things worked, because I'd take them apart and it was a lot of fun. And to this day, I'm constantly fidgeting and taking things apart. Like, no remote in my house is safe. They all get worn out.
Yeah, I was pretty similar. I would always be taking things apart and I never really managed to put them back together. So that was like a common theme.
Yeah, I hear that from a lot of engineers. Just always taking stuff apart, sometimes putting it back.
Yeah,
it's a curiosity. It's like, how does this work? Why they do this way?
Yeah,
and
for sure.
Yeah, it's that's what got me into it. And then recently, I found out I've got a family history of a great grandfather who built big things, and that's what kind of turned me. It was right when I was working on Texas Guadaloop that I came to realize that he built like really big things. My grandma, she was born a long time ago. She watched the Golden Gate Bridge get built from her front porch, for instance. So like that old. And her grandfather built telescopes. She said, oh, he built telescopes. And when I say like somebody built a telescope, most people think like,
yeah,
like this big, right?
Yeah.
He built really big telescopes. And he was kind of the Elon Musk of his day. And I drink out of this coffee cup with a slogan he said that says, make no small plans, dream no small dreams. And that was another thing that's very much inspired me to build.
Wow. So were you growing up in Georgia? Is that how you went to University of West Georgia and Georgia Tech?
Yeah, so I grew up about a decade in Oregon, a decade in Georgia, and a decade in Texas. And I spent one fluke year in Florida, and now I'm back in Austin, and I adore Austin. Also, Austin's blowing up right now. It's a great place to be.
Like crazy. I can't imagine a better place to be at a time like this.
I'm waiting for magical things to happen. I mean, they already are, but just like startups, social movements, the best restaurants, the coolest experiences. I think it's all coming here, and I'm so happy to be here alive at this point in my life, at this point in Austin's trajectory. It's fantastic.
Yeah, you hear stories from like.
If you were to go back to Georgia Tech,
Let's go with Gavin. What were you saying, Gavin?
All right.
He was trying to continue the story, but you just hear stories of like Silicon Valley heyday and like San Francisco starting to blow up, and that feels like where we are now with Austin. There's just so much excitement, and everybody's like funneling here. Yeah, there's a lot going on. No shortage of interesting things, so that's really awesome. It's a great time to be graduating.
It's cool to be around companies like Icon, your hat. They're just doing incredible things, and I think they're just an example of the magic that's in Austin right now.
Yeah.
David, what were you saying?
Yeah, I was going to ask, if you were to look back on like your time in Georgia Tech or something, would you have seen yourself in a position like you are now, living in Texas, doing the types of jobs you are? Is that something that you always kind of hoped you'd go to, or is this, it just ended up that way?
It just ended up this way. Like, I went to the Advanced Academy at West Georgia. I moved into a dorm when I was 16 and started taking a full college load. And it was a lot of fun. I really needed a challenge. I was one of those bored kids that you didn't want bored in your class. And I was always sweet, but I had a lot of energy. And the Advanced Academy of West Georgia was incredible because you were surrounded by all these like super nerds. It kind of felt like an origin story in a comic book. And now some of my best friends are like pharmacists, or one guy was a doctor when he was 21, lawyers. Like, you have an interesting problem, you just throw it out to my academy friends and they'll do some amazing things. But anyway, at the end of the academy at West Georgia, I looked around at all the schools, and I only applied to one, which was Georgia Tech, because I said I needed something challenging. And I really liked gadgets. Thank you, Mom. And I applied there and I got in, thankfully. And electrical and computer engineering was the closest I could think of to gadgets at the time. I did have somebody tell me that I was going to fail out in a year because he had been at West Georgia and he went to Georgia Tech, and he really struggled because Georgia Tech's a struggle. So I was a little nervous about it, but it ended up being fine.
Hey, that's great inspiration going into it. Oh yeah, you'll fail out in a year.
I look back on life, and when people tell me I can't do something, those are some of the moments I'm most thankful for. Like, the senior design professor that we had attached to our team told us that we weren't going to succeed with the small scale maglev train. And he said, if you guys continue on with this project, go ahead and add another semester to your college career, because you're going to fail this one and you'll need to have a new project next semester. It's just like brutal. And we very like soberly huddled together after that, looked at each other and were like, are we sure we want to do this? And we said yes. And then we did, and it was awesome.
That's so weird, because it's like the opposite of what your senior design guy is supposed to do, right? He's supposed to motivate you, not say. I guess.
Yeah, but it's kind of like being a parent. Like, if someone's going to do something that you really don't think is going to be a good move, it's kind of your responsibility to advise them and say, you can do this, but it's probably not going to turn out too well. And he just happened to be very wrong. Can I share my screen and show you a picture of the maglev train?
Yeah. Let me make sure. I think you can. Yep.
Party on. Okay. And for everybody just listening in, I just have this obsession with futuristic forms of transportation. I've got like a few pictures of it. And on the left, you see a beautiful copper winding that is the linear synchronous motor of our maglev train. And then we had this really strange permanent magnet levitation configuration. The whole track's 3 feet long, but we got this thing moving down the track. And when the professor saw it working, he said, if you guys write a paper that can be called a paper, you're going to make an A. So we ended up making an A in that class. But that was the first time I realized that you could build something that really was meaningful, and that it wasn't that hard. Like, I was capable of building things that were new and novel and could go do new things in the world. And so that maglev train that we built and that team that I worked with back at Georgia Tech was pretty important to me.
So what was that other picture? Was that a full maglev train that you were just checking out?
Oh yeah. Story time. There was there still is a company called American Maglev Technologies out of Georgia, run by a guy named Tony Morris. And when we were doing the senior design project, we found out there is a full-scale maglev train within like 20 minutes of us. One of the only ones in the world. We got to go visit this. And they had such a clever and innovative design in which they put electromagnets underneath the track, steel beams. And those electromagnets turned on, pulled the train upwards, but then they had a control algorithm so that it wouldn't actually latch onto the track. So it would levitate by turning on and off, really rapidly and levitating it, just using really simple electromagnets wrapped underneath the track. And so the track was made of steel, concrete, and there was an aluminum slab going down the middle that their linear induction motor pulled eddy currents off of and pushed itself. So it was, the whole train had no moving parts except the train itself, the doors, and the air conditioning. And it was almost like a solid state transportation device. It was amazing. But they built this like quarter-mile track, and it was a really inspiring. They didn't end up making it for the maglev train because, as it turns out, huge infrastructure projects, especially in America, are really hard to fund and get acceptance working with like governments and regulators. So they still have a lot of patents and really interesting tech. If there's any investors listening to this looking for interesting alternatives for infrastructure startups, but that was inspiring because they turned on levitation of that thing, and they had this, I think it was like a 20-ton train. It was like a 50-foot long 20-ton train or something. And you could push that thing with one hand because it was levitating. It was just momentum that you had to overcome, inertia. And that was really cool. And we had a very similar demonstration of that when we did the air bearings at SpaceX, because we put like several hundred pounds on the air bearing platform. And then we put like the seat, and people would get on it and kind of like ride it like a cowboy. But the whole point was you couldn't move it, and then you turn on air levitation, and all of a sudden this thing moved like an office chair on wheels. It was incredible. You could move 1,000 pounds with just your hands moving this thing around. And it's supposed to demonstrate overcoming the friction and what that could do for moving a lot of things very quickly.
Yep, we still have that rig, and we take it to all of our events. So it's still a hit.
It is a huge hit. It's awesome.
Wait, so you said the track would like actually pull up the train?
No. So I can't zoom in on this that I know of, but the electromagnets were underneath the steel beams of the track, and you turn the electromagnets on, and it pulls the electromagnets as well as the whole train up. And there's only like an inch or something in between of play here.
Sure, so is that normal in like maglev?
It's becoming more normal.
Because when I think of maglev, I just think of it like floating on top, right? I don't think of it like being pulled up.
Yeah, that is a very good question. There are multiple forms of magnetic levitation and magnetic suspension. I think this would count as magnetic suspension, but for instance, you could run just a permanent magnet over an aluminum plate, and while moving it, it induces eddy currents that push back the opposite magnetic force, therefore causing levitation. For a hyperloop type environment, you need to be moving 30, 50 miles an hour before this pushback actually levitates the train. And so Virgin Hyperloop 1, this was their initial magnetic levitation. If you went to the SpaceX Hyperloop competitions, most all of the magnetic levitation, in fact, no, not all. Most all use this same form of just permanent magnets barely above the track. You get moving on wheels. You get moving fast enough, it'll cause lift. There are other really interesting forms. So there's like it's called a drone magnetic levitation, in which you take circular Hallbach arrays, spin them in opposite directions, and it's the same principle of inducing those eddy currents and lifting yourself up. The Japanese team in 2018 did an amazing, maybe it was 2017, did an amazing pod that moved that way, and they could also change the speeds of rotation relative to each other to maneuver it on the aluminum substrate. So that was really cool. And then, I mean, there's like 4 more levitation that I know of. There's the Meissner effect of using superconductor magnets within a permanent magnetic field. I believe that's the one used in the Japanese maglev train. But most of them, and then there's this one, which is electromagnets pulling up, and a very clever team out of the Netherlands combined that with a permanent magnet underneath it. So you have a permanent magnet and then an electromagnet. And what happens is the permanent magnet does most of the magnetic pulling, and the electromagnet varies that so that it could do very little work. And that Netherlands team transferred into HART, HARDT, and they have a really cool video demonstrating that. And then I'm pretty sure Hyperloop, Virgin Hyperloop, has switched to a similar approach where you use a hybrid permanent magnet, electromagnet configuration to do the levitation at a very low power. That was a lot of talking,
crazy
sorry.
To see. It's crazy to see where all these Hyperloop startups kind of have ended up. I feel like originally there were just so many, and now it's kind of dwindled down a little bit over more recent years.
That'll naturally happen, yeah. Especially with such a tall barrier to entry, like you can't do meaningful Hyperloop R&D without millions of dollars. And we tried to spin out from the original Texas Guadaloop team. We tried to spin out a startup that focused on just a part of the technology. I'll share my screen again. If you guys want me to stop sharing screen, you tell me what you want. But this is the team. We're at Y Combinator because we were pitching aero levitation as a startup, and they had this like really awesome orange room, and they flew us all in for a 10-minute interview and then rejected us. So it was really cool going through the Y Combinator experience. But then we talked to this guy named Michael, who I think co-founded Twitch, for like 10 minutes. And he was like, too many founders. You guys don't have a market in the next like 5 years. So you guys are too far out. So we don't want to invest in you. It's like, okay, all right. That rejection hurts, but that was kind of fun.
Cool experience for sure.
Oh yeah. I mean, anyone who has a chance to go interview at Y Combinator, do it, because it's just fascinating to see how one of the most innovative incubators makes decisions.
Yeah, can you explain a little bit more what Y Combinator is?
Yeah, it is, to my knowledge, the best incubator and accelerator in the world. They're down in Silicon Valley. They have a whole lot of startups apply, and if they get in, they go through a program to help sharpen their investor pitch. And they have some of the best entrepreneurs in the world be some of the teachers teaching you things like what's a cap table, how do you raise money, how do you stay focused on solving a problem, what is the real focus of your startup? Those kinds of things are hard lessons to learn in some cases, but having some of the best people in the world tell their experiences and then show you is good. And then they have a demo day where they have all these investors come in, and their goal is to get as many matches of investors and startups launched, because now Y Combinator has a vested interest, some amount of equity in these startups, and they can help launch those companies. And all sorts of really fascinating startups have gone through that program, including like Airbnb, which is interesting because at the beginning of Airbnb, it was like one of the worst pitches on planet Earth. It was like, we want to rent out an air mattress in our apartment for you to stay when you come to tech conferences. And they saw the value of basically these unused assets, people's air mattresses, and making this marketplace. They invested in it, and then Airbnb is doing pretty well now.
I'd say so. Yeah, I'm living in an Airbnb all summer, so yeah, something to
Yeah,
work. I guess along the same lines, we've talked a lot about transportation, maglev, and kind of that interest of yours. But I know you're also really interested in augmented reality and virtual reality. Could you tell me a little bit about some of your experience with that and projects that you got to take on in that space?
sure. So I'll share another one. Really sorry for everyone listening. You should get on YouTube and watch this. Okay, this is a project in which I used augmented reality in order to build a project. So this is just like a personal project. I'm showing the value as a maker. So I wanted a workspace that was inspiring. I needed my tools to go up on the wall. The traditional solution to this is a pegboard. Pegboard you can buy in these big 4x8 sheets for fairly cheap, but they're not particularly attractive or inspiring, and I wanted something that was. So I used my Magic Leap headset. I used to work at Magic Leap on their product team focused on spatial visualization. And I did something really cool where I had the real world and real objects and my virtual world and virtual objects mixed into one to go lay out what this wall could look like. So I took these hexagons and I just laid them out on the wall of what this space could look like with a really cool pegboard wall made out of hexagons in the background. And in my makerspace, I've got one table dedicated to 3D printing, one for crafts like wood crafts, and then one for electronics. And so I wanted the pegboard wall to support those tools, but also reflect the nature of those workstations. And so that's what I did to put that together. And that's since kind of exploded into a really cool project. My buddy Dylan has a big CNC machine that can work on big sheets of plywood, or in this case MDF. And so we cut out the backboard and you can see it kind of moving around. This is sped up quite a bit. And then this created the backboard that all these mount to. And then you can see the backboard here, the little mounting hexagons, the big pegboard hexagons. And then recently I discovered you could do, instead of dark mounting, you could add light into it by making it translucent. So I found these RGB lights that are in the shape of a little hexagon themselves, and I integrated those. And so now I'm getting those integrated to make what you see behind me.
That's an incredible project. I feel like when people talk about like the future and the tech that 10 years ago seemed just so out there, like AR and VR is definitely within that realm. And just like the ability of what you can do with that real time creativity, it's really insane. It's one of those things that just like used to seem so out there.
Yeah, and it still is. Go ahead, Gavin. Sorry.
That was straight out of Iron Man when you were moving those hexagons around, putting them on your wall, drawing tables and everything. That's insane.
Yeah, the interesting thing about that future is it's already here. Like AR exists. The tools that I used to do that weren't like super difficult to use, or I'm a really crappy coder. So like I'm a decent engineer. I'm a dangerous engineer. I can get stuff working, but then I usually call in someone better than me to make it properly work. But all those tools exist. The Magic Leap headset has been out since like 2018. It's a phenomenal piece of hardware. I worked there for a year down in Fort Lauderdale, and like every day I'd show up to work and it was like living in the future. You had people with these headsets on having shared experiences. They were like looking at a part of the room, having a conversation about something that none of the other ones of us could see. And it was incredible. And then you go, wait, I want to look at that. And they'd like send a link or pop the headset on. And then you'd see the world that they were looking at. And you go, oh, I get it. I see why you guys were so excited about this. Working there was the most fascinating year of my career so far. Also one of the most disappointing because I moved my family down to Florida to go work on one of the most innovative and well-funded startups in recent history. They raised $4 billion so far. And I went down there on the product team, and They had some of the best tech I've ever seen. They had some of the smartest people I've ever seen. Almost everybody was on a visionary level with the stuff they were working on. Like a lot of outfits you work at, there's like 0 to 1 visionaries involved. This one was like a majority visionaries. It was the first time in my career when I was the one being, guys, let's calm down on the vision. Let's focus on solving real problems here. And then for all that to come crashing down, quite a big step back. It almost exactly a year ago was kind of brutal. So they let go of something like 2/3 of their workforce, like 1,000 out of the 1,500 or thereabouts full-time employees. The employees who got let go, even some of the employees who are still there, we call it like the Thanos snap event, because it just felt like a bunch of people got dusted. And it was pretty heartbreaking at the time because we all believed in what we were doing. But then a few months later, after one of the most brutal job hunts ever, because it was during a pandemic, you saw your colleagues landing at like Microsoft and Facebook and Apple and Niantic, all the places that are defining the next generation of this technology. And you go, oh, it's okay. This is going to be okay. Like maybe Magic Leap saves themselves with ML2, which is a phenomenal device. Maybe they die, but what they were going for will live on through the people and through the stuff that they've already established. And it was cool to be there. It was like living in the future for a year. And then I had to come live in the present again, which it's been an adjustment for me.
Why do you think it is that things just didn't really work out for Magic Leap? You talked about the funding, $4 billion. What was it that made them have to lay off like 2/3 of their workforce?
Yeah, I guess also just like explain kind of what they do.
Yeah. So Magic Leap, the best explanation is that video you just saw, but Magic Leap makes this augmented reality. They call it a spatial computer, in which you could still see the world around you through these lenses, but it overlays a digital world in it. And it's not just like little icons or text. It's like it perceives the world around you. It uses 6 world cameras to 3-dimensionally map out the world around you, and then it places things inside it. So the video that you saw, I placed a hexagon on the wall, and that hexagon stayed there. I moved around, and that hexagon was still there. And that's because my Magic Leap glasses mapped out the whole world and kept that hexagon pinned to that point within like, I don't know, 1/4 of an inch in each dimension. It was it's ridiculous how precise it has to be for your brain to believe it. But then once they've accomplished that, it is one of the most intuitive experiences you'll ever have going into it, because you bring a 3D model into the world and it just appears, and then you can walk around it and look at it and talk about it, and immediately your brain goes, oh, this is real. Like, this is just a thing in our room that we're talking about. And then you take the headset off and you're like, oh wait, it's not there anymore. It's that intuitive. So the future is definitely going in that direction with Magic Leap, or spatial computing, mixed reality, whatever the term you want to call it. It might take a while. I think where Magic Leap failed is a combination of hubris and focus on solving problems today. They're absolutely correct in that this kind of technology is what the world needs, and that people can build on it to do amazing things. But they weren't solving today's problem. They weren't focused on partnering to solve those problems. They thought that they could just kind of build this amazing platform, throw a few millions of dollars at developers to build out the rest of it, and that this thing would just take off. There's still a chance. I really believe that they'll make it if they focus on solving problems, but they were just so convinced that the technology they were building was absolutely the right one, that when people said, this isn't solving a problem for me today, they said, but it will in the future. And that's the kind of hubris I was talking about. It's hubris with innovative startups that are that innovative is a very interesting relationship, because you have to believe in what you're doing so much to convince yourself to keep going, but then you can't be arrogant and overlook, the nature of the world. So it's a challenging relationship. I rambled a lot. Did that answer your question?
Yeah, for sure. I remember watching a recent interview with Mark Zuckerberg, and like he's really into AR. I mean, he was talking about like how in 10 years he thinks everyone can just sit down at their coffee table and play a board game with like their grandma in another state. And it was like right when the pandemic hit, he was like, this is so valuable right now because like people are so separated. Yeah, with AR, we can all be in the same room apart. But I mean, Facebook's obviously one of the biggest companies in the world. They can afford to have that hubris and just kind of keep researching without like too much pressure. So I think you're right. Like it just takes like a lot of money, and they obviously have a lot of vision too. So I think they're set up pretty well.
Yeah, I mean, there's like 4 or 5 companies in the running to define AR and VR, and I think Facebook and Microsoft are the most poised to win, because they've got these giant revenue generating ventures, and then they've got a sustained interest in building out this technology. So they're just gonna like invest their way into winning, I think, unless somebody else gets there first. I just want them to solve today's problems, not problems that they've invented, and like Facebook has their focus on gaming at first and then socialization, social aspects. I think Microsoft is going to go enterprise first. They already won the huge defense contract worth $22 billion, I believe, which is bigger than the entire industry was 2 years ago. So I think Microsoft is who I'd put my money on in terms of winning, but you never know what Apple's going to come out with. So it's going to be really fun to see. I just hope it happens quickly and that companies invest in AR and VR, and like for their own purposes, and that these companies have the fortitude to carry it through. But like, there's a really good story about the mobile phone, covered in a documentary called General Magic. Is that what it's called? I'll sum it up in like 30 seconds. These visionary workers at Apple spun out this company in the 80s to go make a computer in your pocket. It had a giant touch screen and speakers. You could make phone calls from it. It could have a map. It could do your email. This thing in the late 80s. And they raised a crap ton of money at the time, built a wonderful device, but it sold like crap because it didn't solve today's problems. They weren't trying to bridge from today to where things are going. They just wanted to release this technology, and they ended up going under. The people who worked there went on to go carry the torch and bring mobile devices in later, and they're some of the most influential like tech entrepreneurs out there. So the idea lived on, but they weren't focused on it. It was really creepy. I was working at Magic Leap and I watched this documentary because I thought it was about Magic Leap, called General Magic, which was what the company's name was. And it wasn't about Magic Leap. It was just kind of a foreshadowing of it. And so I shared it with all my colleagues at Magic Leap, and there was a lot of like, whoa, that hits close to home. And I think Magic Leap has pivoted in the most recent round of funding. They brought on a new CEO, Peggy Johnson. I think she's a lot more focused on partnering with companies to get into their workflows versus trying to do everything in-house and just focusing on the technology. So I think they'll make it, especially with the ML2. That's going to be a really cool device. I think they've got the right focus. But yeah, that was a weird documentary to watch at the time you're kind of living it.
Yeah, that's like, I remember when Google Glass came out and everyone's thinking like, this is the future, this is so cool. I mean, it was really cool, but like, I don't think we were really ready for it. And now I see all these AR things coming out, and it kind of seems like that was like the first General Magic or whatever. But yeah, that's interesting.
Yeah, Google Glass is a similar story. Like, it's going there. There's going to be, maybe the Apple Glass will be very similar in the level of complexity in the device. Google Glass was absolutely onto something. They just didn't bridge the gap, and they're still going. Like Google Glass still sells in enterprise, and there's a lot of one of the biggest use cases for augmented reality is a remote expert. And that's perfect for Google Glass because all it is a camera by your eyes and a little bit of visualization. So you could Skype to somebody, video, Zoom with somebody remotely or Google Meet or whatever. And so I think Google Glass will potentially do really well if they continue to connect with problems of today.
It's weird that you can have the right idea and just have the wrong time, and that changes everything.
Yeah, that's a big variable in the investment community because you can hear certain ideas and realize it's absolutely what's needed and where things are going. But you have to question, is now the time? Is everything you need for that to become true enough now that you can begin investing in it? Or is that not going to turn out true in the next 5 years and the company will die? And I think Hyperloop is a great example of that. In 2013, Elon Musk said, this is what we need to do. And it was like 95% predictive of what like Virgin Hyperloop's doing now. It's very similar, right? We need to build these tubes, full vacuum, go really fast, on demand, point-to-point travel of humans. And that's pretty darn close to where things are going. But he had a lot of other things going on, and I hope that he saw that it was a bit early for that things needed to develop a little bit more before that's viable. And so he pivoted to making the Hyperloop competition, which I think was a brilliant move for a few reasons, but it just kind of incubated the community and the idea instead of giving it a real shot at that time.
So we talked a lot about AR and VR. Are there any other sectors or technologies that are exciting you right now that you kind of are looking to get involved in or are really excited about?
Yeah, AR and VR is one of my main areas, and even I have a day job with CoStar, the CoStar Group, giant real estate company, tech company. They do incredible things, and I'm really interested in different forms of AR and VR within real estate because it's a very valuable problem to solve. And CoStar, in many ways, is very innovative. So I'm excited to see where that goes with CoStar. Other areas of interest are the makerspace, like just what's available to what's more accessible to people these days. Example A. And then transportation. I think infrastructure and transportation, in specifically transportation of goods, is a passion area of mine. Working on Hyperloop, I learned a lot. One of the things that I learned is it's a lot easier to get people bought into moving goods than people. Like if I were to lose your groceries, you'd be like, oh man, but if I were to lose your kid, you would never forgive me. So there's the difference. Another thing I learned is that if you're going to build a tunnel, size matters a lot. The Boring Company went from an average tunnel size of something like 30 feet wide to have cars going through it down to 12 feet is what the boring machines for the Boring Company do. And in their materials, you can see the main reason behind that is that's all they need to move something the size of a Tesla SUV, but also the cost of building a tunnel goes down squared with the diameter, because that's math, right? Like diameter squared circumference. Like how much does it take to bore that tunnel? So the smaller, the exponentially easier it is to build. And then you want to move goods, you want small tunnels. And then I took a lot of really good lessons away from Hyperloop for transporting things like moving one thing at a time, basically packetizing things and going point to point on demand is transformative. And a good analogy of that is information, how information used to move like 100 years ago. There was newspapers, snail mail, and maybe telegrams. And all three of those were incredibly slow and expensive, and a few groups controlled how information moved. You fast forward with the internet and how information moves today, it's all on demand. Everyone has access to it, and it's so cheap you don't even think about how much it costs to send a streaming video to various places around the world, right? And that transformation has been huge because now information can just, as soon as it's ready to go, it takes off. You don't have to group it together with other people, a bag of mail or a big newspaper to go get that information out. It just goes. It's instantaneous. And I think the movement of goods is going to undergo a similar transformation. And so I've got a startup interest of mine in which I'm trying to do that for the movement of goods, similar to what information did, move things 100 times faster, 100 times cheaper. And I do it all on the nights and weekends, so it doesn't impact my day job. But it is a deeply passionate area of mine, is to change how we move things so that we can change how we live and work.
So I guess with that, what would be, or do you want to go more into the technology aspect of that, or is that something that's still a little hush hush at this point?
I'll share what I can, which is the reason I'm so enamored by the maker space is because the same technology that you can use in the maker space, you can get pretty far on a hardware startup or robotics startup. Like 3D printing, like the Prusa. There's a Prusa Mark III. This is a Prusa Mini. If you, fair notice to everyone, if you are interested in getting into 3D printing, I would 100% recommend the Prusa Mini as your starting point, because it's like $300-400, and it just works. It's got one of the more features than most entry level. It's a little bit more expensive for a slightly smaller build volume, but this thing can travel. You could do print farms with it. It's just like you put something to print on there and it's going to work. It's got a great community around it. So anyway, I'm getting off topic. This is a resin printer. I've got a CNC machine over there, and it's like the tools that we have available today to do electronics, create physical things, is just incredible. So our ability to prototype things, to get them out there, our ability to iterate is just phenomenal. So whereas, like, I don't know, maybe 20 years ago, you had a hardware idea that you wanted to do, you had very expensive shots, very expensive iterations. And now those iterations are 2 orders of magnitude less to make. And so you could just learn and iterate and move a lot faster. And, hearkening back to the Hyperloop lesson that I was trying to drill into everybody's head, it's really important to make lots of cheap iterations to learn quickly and cheaply. And so, like, I'll go here first. David, were you around for the propulsion sled?
I think David just disconnected.
Oh no.
I'm not
Well,
sure.
I'll tell this story, and then I'll try to be quick. So the team was trying to build a propulsion system, and of course they built it in with like a $10,000 motor and a $10,000 motor driver and a $10,000 battery. And if they get it wrong, it's a $30,000 whoopsie. And I said, what can you build in 2 weeks from now? And so they found this existing scooter tire with an in-hub motor and battery. And I said, make a frame for it to go on our Hyperloop track, because we built this 150 foot test track out at the Pickle campus. And they built it out of like wood and roller skating wheels. And we were able to functionally test a propulsion design. And we learned a lot in like 2 weeks instead of a $30,000 6-month learning cycle. And so I took that and I did a guest lecture at UT about project management, especially when it comes to like innovative engineering. And instead of taking the approach of like, think about it really hard and then start building at the last minute and then see if it works. Like, see what you can build in the next week and go build that and learn, and you'll fare much better using that approach.
Well, that's what it's all about: prototyping, rapid iteration. That's kind of why we love Texas Guadaloop, because like the only thing stopping us from doing something is ourselves. If we want to go buy something,
Right.
or build something, is we just go do it.
Exactly.
But I know you got a time cut off, so we'll end it here. Thank you so much for coming on, Ben. And
Sure.
yeah, we had a great time.
Thanks for having me. I hope that was interesting. I've got a couple questions for you. Is that okay?
Yeah, for sure.
All right.
Absolutely.
What is next for Texas Guadaloop?
That's a great question. We have a couple things in the works right now. Obviously, with the Hyperloop competition looking like it's no longer ongoing, it's kind of on us now to figure out where we want to take the team. So we're currently pursuing a couple different kind of more pairing up with a company type routes, and whether that would be doing more specific research within that realm, or maybe even something that looks more like an inter-team competition or something like that. Talking with other Hyperloop teams, we've got a good coalition going where we have semi-consistent meetings with the other U.S. and international Hyperloop teams.
Excellent.
Outside of that, we've also kind of looked at, all right, if for whatever reason we realize that we need that competition structure to really be successful, then maybe we want to look at the bowling competition a little bit more seriously next year. Or maybe we want to look at just, what is our member base really passionate about? Is there, one project that they're really passionate about, and maybe we should just use our resources for that competition or not? So that's kind of some of the things that we're working on. We're kind of going down the list, kind of like a decision tree here. Ideally, we want to stay with the Hyperloop, but whether or not things work out with that will kind of lead us to where we end up in the next year or so.
Yeah, I think that's a great direction. I think this podcast specifically is brilliant. We at Texas Guadaloop, we were working on some of the most exciting engineering on planet Earth, and it's like we kept it all to ourselves. And this podcast is inviting the rest of the world in to join the conversation, have some fun. And some of the people that you have gotten on the show have blown my mind, like Dr. Leon Vanstone, Josh from Virgin Hyperloop. I mean, why you even have me on is beyond me, but I'm very grateful to be on. But inviting people in this conversation is so critical, and you guys are doing great work with it. I think the idea of the competition as a good form of inviting more people in and experiencing not just Hyperloop, but this kind of engineering that's really exciting and important. Yeah, it introduces people to innovative engineering and tangible engineering. So I think it's really important. We've been kicking around this idea of Hyperloop TV, in which we make more of a reality show around the competition of Hyperloop. And I know that we're talking about that, but I think that's another instance of a brilliant way of inviting more people into the conversation. And my friend Andrea, I used to work with her at Expedia, has pulled this off before. And I think a TV show where you have a competition or mini competitions and invite the rest of the world to learn about what it is to build, how difficult it is, but also how not difficult it is and how much fun it is, I think will just inspire so many people to go and build. I think it's really important. And plus that kind of exposure will give you more opportunities. And so I think during this time of uncertainty with the Hyperloop competition, getting the word out, inviting more people in, inviting the world in to have this conversation with you is brilliant. And I applaud what you guys are doing.
Thank you. We appreciate it a lot. I think, talking about like the learning aspect of it, when we really like sit down and talk about, all right, what is Texas Guadaloop about? Yeah, it's about innovating Hyperloop and all this stuff. But at the end of the day, it's really about giving these opportunities for students to really have this learning that you don't get anywhere else.
Absolutely. I think what it does for the the biggest winners of all this are the students who go and engineer and try stuff. Because just sitting in class learning the theory, it'll bore you to tears. And it's so hard to wrap your brain around. Like, how many of us just crammed for tests and forgot it immediately versus going and building? And it's something that's inspiring you. Like, I think it's really brilliant. While I was in Austin in 2019, I was trying really hard to become a professor at UT, and I wanted to start a Hyperloop or Future Transportation Research Center there because I wanted the experience for what the dozen or 24, really like a dozen students get every year of being really involved in the lessons they learn. I wanted to open that up to hundreds of students, whether they're engineers or not, because even Gavin, as a business major, how much more interesting is it to think about business problems and learn about business through the mechanism of Texas Guadaloop versus the books you're reading?
Yeah, no, for sure. And like me always being interested in engineering, it's really cool to be involved in an engineering project, but not like have the engineering expertise. And like with every engineering project, there's a ton of business problems you have to solve, right?
Ton,
I'm sure you
yeah.
know this firsthand. So yeah, it's just a great way. And like you learn things for sure that you would never learn in the classroom, like about business and about project management and like how to build relationships with different people and different partnerships. Those are things that you like can really only learn if you do them.
Yeah.
And you can't really do that like in the classroom. So yeah, it's definitely like one of the more valuable experiences for me.
It's incredible. And Texas Guadalupe has raised hundreds of thousands of dollars, like definitely tens, but I think over 100. And so the business part of it is every bit as important. And like if Texas Guadalupe went and engineered the most amazing award-winning pod in the world, which we got pretty close to, and then no one heard about it, you didn't partner with anybody, maybe somebody just handed you a check for $100,000 and then you went and engineered the best thing in one. Like, that would do nobody any good. It's getting the word out and inviting the rest of the world in as part of that journey that's so valuable to UT. I mean, Texas Guadalupe has gotten on TV shows and in the media. And I think that's all just been wonderful.
Yeah, there's definitely
insane opportunities.
Definitely two halves to the story. That's why we kind of decided to do the co-president situation, because like we think each side is equally as important. And it's
Totally.
working out really well.
Yeah, Deb was our business lead back in the day, and she was invaluable in getting us off the ground, connecting us to people. She was always hustling. It was phenomenal. I think the more things that you can explore like that, the better. And so I'm glad you guys took this approach. Back to the partnering with UT and that business part of it. Anything that you can do to get in a deeper relationship with UT would be great. I mean, getting an ongoing program with funding would be phenomenal, and that's what I was gunning for with the Hyperloop Research Center or the Future Transportation Research Center. I think that Dr. Vanstone with his rocket group was amazing. I was like, I want to do that. Except he very luckily had a billionaire show up and offer $1 million to go start that. And if there's a billionaire out there looking for something awesome to invest in, I would say the Hyperloop group at UT is definitely a great place to invest because, I mean, without even meaning to, it already spun off one startup and an idea that was pretty strong. Like, I can only imagine how many startups would come out of a research center like that and how inspired the students would be. So UT, if you're listening, investors, if you're listening, this is a good area to invest in. Talk to Gavin and David. And another request to the world is in becoming a professor. I want to teach when I grow up, and I really want to be a professor. And I was able to do a guest lecture at UT. I wanted to become an adjunct professor, but the two professors that I look up to and have spoken to about this before both said, don't get into it. It's very political. It's all about how much research you can do and how much money you pull in. And, they themselves didn't want to be in academics forever, which is kind of heartbreaking. So if you're a professor who loves what you do and would encourage other people to do it, I'd love to talk to you just to get that perspective.
Yeah, that's definitely one of the things that the more I get into like academia, I hear more and more about it. Like it's definitely there's a lot behind the scenes and a lot more about what's your research, what's generating, what's pulling in, than what you would think just initially.
Yeah, it's like as an engineer, when I found out that schools spend more on their sports teams than they do their engineering department, they're an engineering school. It's like, what's going on here? But I went and got my MBA, and you learn about the economics behind what sustains an operation, and to realize that you spend money on research, it's kind of a one-time shot. You spend money on a football stadium and it generates revenue continuously forever. Yeah, you start to understand how economics drive school decisions. But it is kind of heartbreaking, that schools have such torn interests in that perspective.
Yeah, I mean, at the end of the day, schools, like in a way, are businesses, but that's why we love these different student orgs, because it gives like students a way to sort of get out of that and like kind of step into the real world before they have to graduate and like actually go do that.
And it's this playground of being able to start organizations and go for something, maybe get some support and funding to go for it, is more of a recipe for innovation than most corporations have. So it's awesome. I really, I love what you guys are doing. I love the university setting for things like this. Like Bob Metcalf was leading the innovation center, I think, for UT for quite a while. And I think it's absolutely brilliant.
Yep. So, are you out of time? We can keep going.
I probably have time for one more question if you have one, or I have a question.
Okay. Yeah, you can ask your question, and then I'll try to sneak one in.
Okay. Or David, do you have a question?
I'll let Gavin go with his question first. I think we probably have the same question.
All right, go ahead.
I don't know. I was just kind of wondering, like, what is your advice for like graduating students or for people who are interested in pursuing these projects, like after they graduate? Like, how do they find a path to success? What resources do they have? Just based on your experience, like doing similar things, what would you say to someone who's in this situation?
That's a great question. I think it depends a lot on your personality and what you need out of life. I am an incessant builder and dreamer, so I need an outlet that allows me to create and to build from scratch, from 0 to 1. And if you look at your own personality and you think, I just really like working on hard, challenging problems, then that's a different set of advice than I'd give to somebody like myself who's got kind of a need to work on novel things and to learn and to build. And so for those who are like me, I'd say take care of your basics first. If you've got student debt, don't go work for a startup in the middle of Wyoming building new aircraft designs that doesn't pay you. Go take a job that pays you so you could pay back that student debt. This is a trade-off that I myself had to take. And then if you can, work somewhere that gives you a little bit of that outlet, or at least fuels it. National Instruments, when I joined with the engineering leadership program, was perfect for this. Had a lot of insanely intelligent people working on cool problems. I can't tell you how many support calls I took that were really, really interesting stories in themselves. But don't optimize. If you're like me and you need to build, don't optimize for the biggest paycheck. Optimize for what best fits you and just make sure it covers what you need. So for instance, if you're like super creative, maybe go work at a company like Icon. Or if you have a need to serve the world and have a greater purpose, like don't go work for a large tech company that steals all your private information. I'm not saying people who work there, I have any issues with them, but serve yourself in what you need. Another great example of a really innovative company that is helping to serve the world, back to Icon. Like they're building two of the coolest things I've ever heard of with 3D printing houses and trying to help with homelessness and housing all around the world, but also moon bases. Like, go work there. That sounds phenomenal. And there's a lot of companies who can build a good business model and are growing, working on really interesting things, but are also very inspirational things. So don't optimize. If you have other needs like that, don't optimize for the paycheck. And job hunting is brutal. Build up a community around yourself for that job hunt, because very few of us will go, I want to go work there, and they apply and they get it on their first shot, and then they just get to go work at their dream company. Most of the time, it's a brutal process. So you need people to support you and to give you advice, help review your resume. And then you just have to have a ton of patience and faith that things are going to turn out, for the better. Cause like my job hunt was 3 months during a pandemic, which is relatively short, but we were in Florida. We left Florida. We were living with friends and family, like bumping around while job hunting. And it was just silence and rejection for months until it lined up. And, I'm somebody who's got a lot of product experience. I interview well, and it's just a kind of a brutal scene right now. So that's a lot of advice, but that's what I'd say.
Definitely great advice.
Yeah, and it's still inspiring to see you with your makerspace and your workshop, still pursuing things you love. So that's awesome to see.
3D printing as we speak.
Yeah.
Little mounts for those lights. So this camera doesn't capture it too well, but there's these translucent hexagons that mount to the backboard, and then the pegboard mounts onto it here, and then it has space for that little RGB LED. And this is the same thing that's holding all these pegboards up. I'm going to expand this all the way out to here. And so maybe next time we have a video call or you guys get vaccinated and come visit, you can see it built out a little bit more.
That's going to be awesome to see.
It's really fun. It's cool to build up your space so that when you walk into it, you go, oh, this is cool. Let's do some fun work. Let's get to it, versus like, I don't know, a lot of office spaces are pretty uninspiring.
Yeah, I think it's definitely important to have those personal projects too, because it's so easy to, just do the work for the company, and then you don't really do anything for yourself. But that's what brings you back to the original love of engineering, and just tinkering things.
Absolutely. Like spend the time and the money on yourself, because you're doing all this work to support your lifestyle. Remember to live your lifestyle. And like you guys probably aren't experiencing this so much right now, but as soon as you get out into the workforce and you're working really hard and you're really inspired to do your best work, you don't leave yourself a lot of energy or time when you get done working 60 hours a week. So like invest in the relationships in your life, in the friendships. Talk to your parents on the phone, go hang out with those people, like put in the effort, because those pay back much greater dividends than working an extra hour and then crashing when you get home, or like not having the energy to really be present with a person you're in a relationship with, or using the time to go exercise or something. So like invest in yourself.
Great life advice.
I didn't mean for it to be so advice heavy. I feel feel a bit
No, that's
rambly,
good. That was
but
great advice.
appreciate
I
you
think
guys
I'll-
listening.
We're a self-help podcast now.
Yeah. All right. Well, I'll let you guys go. Thank you so much for having me. I'm greatly humbled to be invited. I remember when you guys started doing this, I was like, I hope they ask if I can I could get on. Then I saw Vic on there. I was like, oh, come on. I could get on there. And I'm so grateful that you guys invited me. I hope it was enjoyable. I wish you guys well. Anytime you guys need help or advice in terms of Texas Guadaloop or outside of that, please reach out to me. Anybody listening to this podcast, like, do the same. This is a short life we have. Don't be afraid to reach out and ask for help or advice or whatever. And I don't know. This is great. Thank you.
Always great talking to you, Ben. Thanks for coming on.